In this video, we are going to finish up our discussion on section 8.2 and 8.3. This is series solutions about an ordinary point. I'm not going to explain the whole method again or anything. This is just a second example. So the first thing I'm going to do is make my guess. So my guess, and like the last example, give yourself plenty of room. These can be pretty long. So y equals what I'm going to do first is the summation of n equals 0 to infinity of c to the n x to the n. That was our series. That's a general solution for a power series. We then need to fill in our dE, so I got to find a derivative and a second derivative. So we know from the past videos that the n to c just goes up by 1. We don't have to do that, but it is going to make our lives a little easier in a moment. So we get n equals 1, and then we're going to get the n comes down times cn x to the n minus 1. And then we can also take a second derivative. That's going to be the series as n equals 2 to infinity of n times n minus 1. That doesn't look good there. N minus 1. C to the n x n minus 2. All right, and then we're going to sub that into our problem. First thing I'm going to do to kind of help out with how this is going to end up is I got to multiply this and that by this. Like I got to distribute there, right? I don't know why I did that in highlighter, but this has to go to both. Think about if I multiply this by x to the second, I'm going to have x to the second times x to the n minus 2. That's just going to result into an x to the n because I add my exponents. And then times 1 is just going to repeat it. So I'm going to write that line down. Right, pretty small because you got to fit them all in here. The summation, this is going to be the 1 times x to the 2 to result in that. This is going to be n equals 2 to infinity of n times n minus 1 times c to the n x to the n. That's the first one. That's because I multiplied here. Just a reminder, times 1 now. I got the summation n equals 2 to infinity of n times n minus 1 c to the n x to the n minus 2, because that one wasn't corrected. That was times 1. Plus, now I'm multiplying x times the first derivative. We have the same case here. It goes inside, so I got x to the first times x to the n minus 1. I add my 1s, they're gone, so it just becomes x to the n. So this is the summation as n from n equals 1 to infinity of n times c to the n x to the n. Right? Don't have to correct that one. And then we just have a minus, just our guess. So c to the n x to the n, and this is ran from 0 to infinity, and then this equals 0. Right, so this is the same as last time. We're going to sub our index to match our x to the n's. So this one's going to be n equals k, or k equals n, I guess is how we were writing it. This one's going to be k equals n minus 2, which means n is k plus 2. We're just going to try to get x to the k all the way across, and then these are nice and easy. X equals, k equals n, and k equals n. The only thing we actually have to change is that second one. The other ones we have to change the k's. So the summation of k equals 2 to infinity of k times k minus 1, c to the k, x to the k, plus, okay, so we have the summation now. N is 2, so my formula says to minus 2 to get k, so that's k equals 0 to infinity. I replace k plus 2 to n. K plus 2 minus 1 is k plus 1. Then I have c k plus 2. And then x to the k, that was our goal. The third one, nothing changes. These last two, we just change them to k's. So I'm just going to write that. All right, that's replacing all those. So that was the sub the index. The next part was to let out terms. Remember, we want to get them all on the same, to be the same, and to let them out, remember, if we let one out, the k goes up. So it looks like the highest number is k equals 2. So for this one, I'm not going to let any out, so I'm going to put a box with an x. This one is k equals 0, and I got to get to k equals 2, so I'm going to let out 1 and 2. Okay, this one, I need to get to 2, so I got to let out 1. And then this one, I got to let out 1 and 2. If I do all that, then they will all be k equals 2. That's the goal there. So I let all those. Okay, the first one doesn't actually, first I write down the ones I'm going to let out first. So k equals 1, that is going to get me, if I plug in 1, we get 2, C2. If I put in 2, I get 6, C3, X. All right, so that covers this one. That one doesn't have anything. K equals 1 on this one is going to give me plus C1, X. Okay, we're done there. And then the last one we got to let out, hold on one sec. I plugged in the right numbers because I'm going from notes, but this we should be letting out 0 and 1 and 0 and 1. Sorry if I messed you up there. We got to let out 0, 1, 0, 1. So we've done all that's there. Now I got to let out 0 and 1 for the last one. The good thing is what you wrote down, if you wrote that down, you have to change 0 and 1. That's it. The rest of it is good because I'm using my notes with plugging them in. Now I'm doing k equals 0 here into that summation right above. So that's minus C naught and then minus C1x. Right? That's all four of those. Now I get to write down all the summations with them moved. K, they should all have k equals 2. I know that's what I moved them to, so I don't have to think about it. All right, so I write all this down. I think the worst part about these problems is how much you have to write. So k plus 2, k plus 1, c to the k plus 2, x to the k. I'm going to go down 1 so I don't have to shove these in here. E to the k equals 1 to infinity of k times c, k. Oh, they all should be 2 now, so that should be a 2. C to the k, x to the k, minus the summation k equals 2 to infinity of c to the k, x to the k, and all that mess equals 0. Okay, so now what we're going to do, this one's different from the last one, just slightly. We can add our sums, we're going to do that, but the terms out front, we can actually put them together with constants and non-constants. First thing I want you to notice is that's gone. Those are canceled. C1x minus C1x are gone. So I'm going to group the first two. That's 2C2 plus or minus C naught. That's my constant term. The second term is going to be C6, and I'm going to put it in parentheses just for the sake of argument there. I know I could have left them off. And then now I can do my summation. The summation is k equals 2 to infinity, and now I can put it all together and leave, we'll do a bracket here and put our x to the k at the end. So we get, okay, bracket, and then I keep doing that, k times k minus 1 times c to the k, plus k plus 2 times k plus 1, c to the k plus 2. And then our last two here, we got plus k, ck, and minus ck. All that is x to the k. And we do that now. I have those three terms. I can create a system because I know each coefficient of the x term has to be a 0 because that's the way these polynomials work out. So my system here is 2c2 minus c0 equals 0. 6c3 equals 0. And then the last thing there, k times just the inside, right? We get to drop the rest. K minus 1, ck, plus k plus 2 times k plus 1, ck plus 2, plus k times ck minus ck equals 0. Ooh, okay, so notice we do have all those ck's. We can put those together. Let's do this first. Okay, I'm going to solve for c0. C0, if I add, no, let's add for C2. Let's do that. C2, if I add C1 over and divide, I get 1/2 C naught. Cool, that's going to be something we're going to use. And then this one implies that C3 is equal to 0. So we're good there. All right, the last equation, we're going to solve for the biggest C sub. So I have ck plus 2, and let's put those together actually first. So I'm going to do k plus 2 times k plus 1 times ck plus 2. I just wrote down the second term. And now I'm going to put this, okay, I got k times k minus 1, ck. And then notice I can factor out that ck on this next part. I got k minus 1, ck. These two, I can factor out ck. I can then put those together. K plus 2, k plus 1, ck plus 2, And then I can factor out the ck here. So we get k times k minus 1 plus 1 times k minus 1 times ck. And then we actually have one more step here. Rewrite. We have more steps, but we can simplify one more time. I don't know if you guys remember seeing something like this, but you actually can factor out that k minus 1 and end up with a factored pair there of ck. All right, there's a plus sign between. All right, now we're solving for the c sub that is bigger. That's k plus 2. So we get ck plus 2. If I subtract the right term and divide, okay, I get k plus 1, k minus 1, over k plus 2, k plus 1, ck, and then doing that, I had to subtract it over. So I subtract that over, I have that. The k plus 1s are going to cancel now. So here is my formula that we're going to use. We got the negative, okay, so this cancels, and then the negative distributes, and I can do that over k plus 2. That's just the negative through k minus 1, ck. And then this is for k equals, we just look back at our summation, it started at 2. And this tells me where to start. Right, so now I start building my list. So for k equals 2, we have C4 equals, and I plug that into my formula, I get negative 1/4 C2. But I know what C2 is. C2 at the top here, let me scroll up a bit. C2 is, so let me write down my negative 1/4, and then I'm going to replace C2 with 1/2 C naught, and that is negative 1/8 C naught. All right, so there's our first one. K equals 3. So I get C equal C5, C sub 5. And then plugging that into the formula, I got negative 2/5 C3. But C3, if I look up, is 0. So that's 0. K equals 4. So I get C sub 6 times negative 3/6. That's just using the formula up there. I just didn't reduce. That's negative 1/2 times, and then C4, if I look, it's right above here, negative 1/8 C0. That is going to be 1/16 C0. Right, K equals 5. And I'm starting to suspect a problem. I got that 0. Let's see how it goes. C0, C7, sub 7 is, if I plug that in, I got negative 4/7 C5. But C5, if I look right here, is 0. So this is 0. Okay, I keep going. K equals 6. That's C8 using my formula. That is negative 5/8 C6, which is negative 5/8. And then C6 is 1/16 C0. That's going to be negative 5/128 C0. Starting to see a pattern, I suspect, of C0, then 0, then C0, then 0, C0, and then I'm guessing this one's going to be 0. That is C9. So that's negative 6/9 times C7. C7 is 0, so this is 0. All right, just to confirm, because I'm guessing this next one's going to be a C0, I'm going to do it one more time. That will give me 4 of them. That's perfect. I don't feel like I'm doing more because the others were 0. So this is negative 7/10 C8 using the formula. I get negative 7/10 times negative 5/128. That's C8. And that's going to be times C0. I guess it should have been inside there. There we go. And that is 7 after you reduce it, 256 C0. So I got 4 of them. Now don't automatically just pick up your C0s and try to throw them together. We still need to look at our guess to grab. And this always, if this feels difficult to go through, yeah, I agree. This whole problem is difficult. This part too is kind of hard to write out sometimes. So I always give myself a reminder of what this means. This is C0 plus C1x plus C2x squared plus C3x to the third plus C4 x to the fourth plus dot dot dot. And notice the c's go with the exponents, so I'm only going to have the even exponents. I'm not going to have the odd ones. The odd ones aren't there. The only one that's going to be there is that C1. So I write out my answer. C naught plus C1x. I didn't change any of that. And then I got to start filling everything in. Okay, C2, if I go back up and look, right, that was written right here. C2 is 1/2 C naught. So I get 1/2 C naught x2. Now I know all the odd powers. If we look, because the odd powers, right, 3 goes with 3, then 5 would go with 5. Those are all going to be 0 because my C odd powers are 0. So all those are gone. So now I got to deal with even ones. So that was C2. So now I need C4. So I go up and look at my list. It's negative 1/8 C naught. And this is going to be x to the 4th because it was C4. Right? The next one is going to be C to the 6th, which is 1/16 C0, x to the 6th. Then we have the next one's going to be C8 minus 5 over 128 C0, x to the 8th. And then I got one more. We did a lot on this one. 7 over 256 C0, x to the 10th. And this goes on, remember, forever, so don't leave that off. So there is my solution together with the C naughts and C1s. Now I can actually get two solutions. Y1 of x, we'll call that the C naughts. So C naught is C naught times 1 plus 1/2 x squared minus 1/8. I always want to write my C's, but we factored it out. Plus 1 over 1/16 x to the 6th minus 5 over 128 x to the 8th plus 7 over 256 x to the 10th plus dot dot dot. That's C naught. And then now it's kind of tricky. That was this and all of those. Our second solution is literally what's there, C1x. So our general solution here is C1y or C naught y1 plus C1 y2. The ones and twos, right, are generic. I could have picked 0 and 1 for my y's. But there are my power series solutions for DE. That's as far as we could take it. We actually could go further and throw in some trig stuff with it. We are not going to do that this semester. This is the extent of what we have time for. And then this is all I'm assigning for this week, for this semester. This is fall 22. This is going to come up next semester and the next semester and next semester. But take your time on this. I would do the first video. You're in the third video now, so hopefully you did what I suggested earlier. Watch one at a time and do the homework. What I want to leave you with on this video is to give yourself grace. These are long, they're difficult, and they're very easy to make a mistake in the middle. Just know that your test question will not be won't be as long. It'll be very focused on the method, so the problem will be shorter. And focused, like always, for differential equations, very focused on the grading of your method rather than complete accuracy. Accuracy is important, still very heavy in your grade, but I'm looking for process. So give yourself grace, study the examples in these videos, then do your homework, get those down, and then you'll use the review I will make for this unit to get ready for your exam.